Welcome to Chillers for Beginners, an in-depth guide. If you've ever wondered how large buildings or industrial processes are cooled, you're in the right place. In this comprehensive guide, we will break down the essential concepts of chillers, covering everything from their basic function to different types, components, and real-world applications. Let's get started. So what exactly is a chiller? Simply put, a chiller is a machine that removes heat from a liquid, which is then circulated through heat exchangers to cool air or process equipment. Chillers come in various types, categorized by their cooling mechanism and the medium they use to reject heat. We will explore these different designs and where they are typically used. Every chiller, regardless of type, relies on a few fundamental components to execute the refrigeration cycle. Knowing these parts is crucial for understanding how a chiller works. The core of a chiller operation is the refrigeration cycle. This cycle involves the continuous phase change of a refrigerant to absorb heat from one location and reject it to another. The key players in this cycle are the compressor, condenser, expansion valve, and evaporator. We'll detail the role of each component in transforming the refrigerant to achieve cooling. There are two primary mechanisms that drive chillers: vapor compression and absorption. These represent two distinct ways to achieve the cooling effect. Vapor compression chillers are the most common type, using mechanical compression to raise the refrigerant's temperature and pressure before releasing heat in the condenser. Absorption chillers, on the other hand, use a heat source, often waste heat or natural gas, and a chemical reaction to drive the cooling process, making them energy efficient in certain contexts. Beyond the mechanism, chillers are classified by how they dissipate the heat they remove, which leads us to air-cooled and water-cooled systems. Air-cooled chillers reject heat directly into the ambient air, typically installed outdoors. They are simpler to install as they don't require a separate cooling tower. Water-cooled chillers use a cooling tower to circulate water and reject heat, generally offering better efficiency, especially in large-scale applications, but requiring more system components. Chillers are indispensable across various sectors. Let's look at the main areas where these cooling systems are utilized. In HVAC, or heating, ventilation, and air conditioning, chillers provide comfort cooling for commercial buildings, hospitals, universities, and large residential complexes, ensuring a comfortable environment. For industrial processes, chillers are critical for controlling temperature in manufacturing, pharmaceuticals, food and beverage production, and data centers to ensure equipment operates correctly and products maintain quality. When it comes to selecting or operating a chiller, efficiency and proper sizing are key factors for both performance and cost savings. Chiller capacity is typically measured in tons of refrigeration, or TR. 1 TR is equivalent to the cooling capacity needed to melt 1 ton of ice in 24 hours, giving us a standard measure for sizing. Regular maintenance is crucial for sustaining chiller efficiency. Neglecting maintenance can lead to energy waste, frequent breakdowns, and shortened equipment lifespan. We have covered a lot of ground today. Chillers are complex systems, but understanding the basics makes them much less intimidating. Remember the core concepts. Chillers remove heat from liquid, they operate on a refrigeration cycle, and are categorized by mechanism and cooling medium. They are essential for both comfort and industrial cooling. If you're interested in learning more, consider exploring specialized courses, industry publications, or seeking advice from experienced HVAC engineers. Thanks for watching.